Okay, good day. This is dual enrollment pre-calculus. I am Mr. McCulley, and this is lesson number 30, the law of cosines. Let's get right to it. So today we're going to use the law of cosine to solve oblique triangles. We're going to use the law of cosine to solve some problems, and then we're going to use Herons formula to find the area of oblique triangles. So the first thing is law of cosine. And law of cosine looks a little bit like the Pythagorean theorem. But this little, and so you can kind of think of it as a Pythagorean theorem with this little bit of difference to say that that side opposite the quote unquote right angle is decreased a little bit, or by whatever that angle is. And so the real thing that you got to think about is that when you set this up, is that no matter what sides you're talking about, the angle that is going to be included, either the one that you're trying to find when you have three sides, or the side that you're trying to find when you have two sides and an included angle, that the angle and that side that's opposite are these two parts. And so the book shows you 6 different forms of the law of cosine. We're just going to memorize one and put it to the situation that we're given. And again, this thing is very good for solving angle side problems and side problems. Side, yeah, 3 sides. And so if you have 3 sides and are looking for the angle opposite of one of those sides, you can use the law of cosine, or if you're given 2 sides with an included angle, you can find the opposite side, which is what we're going to do in the first example here. Oops, I forgot. We got to talk about Herons formula first. Now, Herons formula, you can find the area of a triangle without knowing what the height is or what any of the angle measures are, just using Herons formula. And if you know what the 3 sides are, what you got to do is you add those 3 sides up and you divide it by 2. So we're dividing it by 2, not 3. So this is not an average. It's the 3 sides added together, divided by 2. And that is a factor that they call S. And so the area is just the square root of the product of 4 values. The S value, S minus A, this side, S minus B, that side, or the length of those sides, and S minus C, the length of part C. So we'll have one example of that as well. So here we're going to have solved the oblique triangle, given that, and we'll just fill in our blanks. We'll call this A right here, and that's going to be 48 degrees. We'll call this big B, and then this little short side, little b equal to 3. And then we'll say that this is C, and we'll call this longer side 14, little c. And so this will be little a. And so here, clearly, we can see that we have a angle side situation. We have an angle with an unknown opposite side. So here is definitely a case for the law of cosines. And so in this case, it's not going to be c squared equals a squared plus b squared minus 2ab cosine c. Because the way we have it labeled, we're going to say that a squared is equal to b squared plus c squared minus 2bc cosine big A. And so we're modifying that equation to the situation that we're given. And so A is going to equal the square root. We'll get it by itself. And again, normally if we take the square root of both sides, we say plus or minus, but clearly this is a positive distance. The B squared it'll be 3 squared plus 14 squared minus 2 times 3 times 14 times the cosine of A. We'll put that right there. I don't have my graphing calculator up, so we will record right back to here. Okay, so we need second square root, and it was 3 squared plus 14 squared minus 2 times 3 times 14 times the cosine. And just to be safe, let's check our mode. We are in degree mode. That's good. We'll quit out of there. And now they put me out. That's okay. It's better to check than to have to come back. And it's 48 degrees, so let's go 48, close our parenthesis, hit enter, and we get 12.198. 12.198. So A 12.198. And just to be consistent with what I've been doing, let's make a list here. So angle A, angle B, angle C, little a, little b, little c, and this will be our answer when we're finished. And so this is 48 degrees. Little a we now know to be 12.198. I know that little c is 14. All right. And I know that little b is 3. Okay. So let's solve for angle B now. And actually, because we know what little a is, and we can't do it any other way, we're going to have to use a derived answer. But I've got angle in its opposite side, and then an angle in its opposite side. So I don't have to use the law of cosine for this one. I can actually go back to the law of sine and make it nice and easy for me and say that the sine of 48 over 12.198, and since it's a derived answer, I'm going to use the answer function on the graphing calculator, equal to the sine of b over 3. And so cross multiply, divide, take the arc sine, and you'll get b equal to the arc sine of 3 sine 48 over the 12.198. So we'll do that. So I'll go to my graphing calculator and go second sine. We'll go alpha y equals to bring in a fraction. And then we'll go 3 sine 48. We'll close that. And then we'll go second answer, and we'll bring that to 12.198 with all the extra decimals in. Pull parenthesis there, hit enter, and we get 10.531 as our angle B. 10.531. So 10.531 degrees. And then angle C, we'll use the triangle sum theorem, and we'll use all the digits to keep our error down. And so angle C will equal 180 minus 48 minus the 10.531. Nope. Okay, so 180 minus 48 minus second answer again, and we'll use this answer. We'll hit enter. So 124.469. 124.469. 124.469 degrees. We'll put our box around that, have all of our answers together, and then we are good. Next example, find the area of the given triangle using Herons formula. So I have a triangle that has 3 sides. So if we really just wanted to draw it, we could say that it's a triangle that looks kind of like this, where this is 25. This one here, that's along the side 35, and here's 32. And so the first thing we want to do is we want to find that factor, that S factor. So S, and I don't like using S's because it makes me looks like my 5s. But what are you going to do? So it's 25 plus 32 plus 35 all over 2. So that S value, 25 plus 35 plus 32, hit enter, and then we divide that by 2, hit enter again, we get 46. Okay, so S is 46. So Herons formula says that the area is going to equal that 46 times 46 minus each of these individually. So 46 minus 25, 46 minus 32, 46 minus 35. We get a square root 46. Let's see here. You know what? Let's just do it in a calculator. We'll just do it in the calculator. Let the calculator do it. We'll move on. All right. So second square root 46 times 46 minus 25, 46 minus 35, and 46 minus 32. I think that's right. check to make sure we're good. All right, hit enter. So 385.699, because it wouldn't round 3 decimal places. 385.699. 385.699, and that's units squared because it's area. All right, a application problem. Okay, so this one says find the angle in the design of the street lamp shown in the diagram below. So I'm copying the diagram. It looks a little bit nicer in the book than mine, and the little street lamp is right here. And so they want to find that angle, given the fact that we have this little arm there plus a support beam. So the arm is 3, and it doesn't really matter what the units are because we're trying to find the angle measure. And so the support bar is 4.5, and the distance from the top of the pole to where the support beam meets the pole is 2 feet. So here is an instance of side, 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 and they're asking us to find an angle. And so if I set it up as, if from the formula that we had before, c squared equals a squared plus b squared minus 2ab cosine c. So in this case, we're actually trying to find the angle measure, and we're given those values. So let's just go through the process of solving for c first algebraically, and then you'll see how they get a couple of those other formulas that are in the book. So to get c by itself, first thing we got to do is we got to move the additions over. So if I move the additions over, I'll get c squared minus a squared plus, excuse me, it's going to be also c squared minus a squared minus b squared equals negative 2ab cosine c. So let's flip it over because we're going to try and get c by itself. And so we'll go negative 2ab cosine c equals c squared minus a squared minus b squared. And then we'll divide by, since we got the multiplication, we'll divide by negative 2ab. So we'll have the cosine of c is equal to c squared minus a squared minus b squared all over negative 2ab. And then we'll finish it off by taking the invert arc cosine of both sides. And so c is equal to the arc cosine of c squared minus a squared minus b squared all over negative 2ab. And that's what we're going to put in the calculator. So I go and I grab my calculator, second arc cosine, and then I don't need that parenthesis there, so let's delete that. Second alpha, bring up my fraction, and so we got to determine our c squared. Now, because theta is opposite of this 45, we're trying to find that angle, so we have to use, or not 45, 4.5. The c squared is going to be the 4.5. The a and the b doesn't really matter. We'll just plug those in as is. So we do have to have the 4.5 squared there, and then it'll be minus 2 squared minus 3 squared all over negative 2 times 2 times 3. Close off that parenthesis there, hit enter, and we get 127.169 degrees. 127.169 degrees. That's it. And that's all I have there, folks. So today's Star Wars fun fact of the day: the characters of C-3PO and R2-D2 were so popular back in the 80s that ABC ran a Saturday morning cartoon called Droids. Unfortunately, it wasn't very good and only ran for one season, but you can watch the opening on YouTube, and it is worth your time. It's quite the 1 minute and 5 second song. That's all I got. Have a good day.